How's it going, guys? You're looking at a dryer here running on 120 volts on a 3500 watt pure sine wave inverter, a cheapo, $250 inverter. And the cool thing is it's running the hot water heater and the entire rest of the house all at the same exact time, and I'll explain that in a second. So in the event of an emergency or long-term grid down, you might want to be able to run your house on 120 volts. And obviously that's something you could only do during an emergency, or if you're off in an off-grid cabin, normally house wired for a pair of 120 volt legs and one neutral. The way that this works is the dryer uses the pair of 120 volt legs together to make 240 to run the heating element, and it taps into the neutral in one of those legs to make a 120 volt circuit for the motor to spin the drum, and also inverts DC to run the computer electronics. So in order to switch this to 120 volts, you would need to figure out which one of those hot legs is not tapped in with the neutral to make 120 volts. In other words, you clamp both of the hot legs and figure out which one has less current on it. That's the one you move to the neutral bar, because that's the one, the other one is tapped into neutral to get 120 volts. Once you do that, you're all set. The dryer will run at 1500 watts instead of 6000 watts. It'll still get the job done, especially if you have a high RPM washing machine. And depending on the time of year, of course, you might be drying your clothes on a rack in the on the deck or outside or on a railing or in front of a ceiling fan or something like that. Then you can throw the clothes in here to get that nice hot finish. Even at 1500 watts, this will still get your clothes nice and hot towards the end of the cycle. And now, like I said, the hot water heater is also running on 120 off the same exact inverter at the same exact time. Normally, the hot water heater is 4400 watts on the top element, and once that's reached its temperature, the lower element kicks on, and that's 4400 watts. They have a pair of 120 volt legs that makes 240. It's very simple. Unlike the dryer, there's no neutral to worry about. So you can take either one of those legs, move it to the neutral bar, and you've got 120 volt on your hot water. And instead of 4400 watts per element, it'll use 1100. And instead of an hour and a half to bring an 80 gallon to full temperature, it'll take 5 hours if you ran it all the way, if you let it cool down. Which I honestly don't care. I take a shower for 15 minutes and it's going to recover in it uses about 6500 watts to take a shower. So if you took a 15-minute shower, that's something that would recover in about 1 hour if your hot water heater is running on 120. So you can take a 15-minute shower every hour. It's not a problem. Now, obviously, most people would use a huge 15,000 plus watt split phase inverter. They're very expensive, and you have to have a huge battery bank to be off grid and run these devices at 240 volts. But this allows you to be able to run off of a cheaper inverter in a pinch, in an emergency like a long-term grid down, or again like an off-grid situation. It may not be for everybody, but it's nice to know that that option is available if you really need it in a pinch. Obviously, you have to be qualified to understand how to safely wire if you're going to go inside your electrical panel box. But at least the concept is sound, and the wiring doesn't need to be enlarged or anything like that. Although you might want to pay attention to which, if you were to run these devices on and run your household devices on 120. You have to understand that if you have two separate legs and you're running a single 120 volt inverter, you essentially would have to jump your legs together in the house. That's something that obviously you would not want to do if you're connected to the grid, or unless you really know what you're doing, or you're experimenting, or again, we're in like some kind of long-term off-grid emergency. But it can be done, and it's important to know that. And of course, most people are not going to be able to, a lot of people are not going to be able to afford a gigantic 48 volt battery bank with a huge 15,000 watt split phase inverter. So if a $250 inverter can do that job, that's incredible. And it does. It's running I can run this hot water heater and the dryer at the same exact time as the entire rest of the house. It's daytime right now, but we're talking, I have a couple of refrigerators that are high efficiency, lights here and there, a few fans here and there. Nothing much. The background usage on the house is about 150 to 200 watts typically. So add that together and you're still well under the 3,500 watts continuous load duty on this inverter, which I'll show you in a second. So here it is, guys. This is literally actually running the entire house, dryer and hot water heater all at once. This is a 3,500 watt continuous pure sine wave inverter. Now it's not actually drawing 3,300 watts right now. That reading is high. I'll clamp the battery and I'll let you guys know 1 second what we get. Well, I couldn't clamp them after all because my clamp meter only goes up to 100 amps, and we're on a 24 volt battery here, so well over 100 amps. The actual power coming out was 2800 watts roughly, and this display is actually showing more along the lines of what power is coming in, which is probably about 3100 watts. And maybe that's what the display was intended to show, but it always does read high. Anyway, it goes to show you that a cheap inverter has pretty good performance. I've been using this reliably for months, running the house this way. And again, it's an experimental thing just to see what can be done. And you're not limited to just one inverter. I have two inverters on this system that are hooked to these batteries, and you can run two separate groups of loads. If you have a critical loads panel with a switch, you can just use that as a transfer switch to run those other loads. And so in that way, if I have too much solar power coming in, the batteries are already full, I can burn off some of that extra power up to 6,000 some odd watts. I even have a third inverter, but that's hooked up on a 12 volt battery bank that's separate. So if you have, you can run a separate load, like maybe a dehumidifier or something like that, just directly off of those inverters without tapping into any of the house panels and wiring. I guess also worth mentioning that this inverter has a 7 watt standby power, and I've measured it to be roughly 91% efficient. It's actually a little bit more efficient than my Samlex 3000 watt 24 volt inverter. So those numbers are pretty impressive for the price. I think this was like $250, $260. I'm not trying to advertise for this company necessarily. I'm sure they probably rebranded this inverter, but these are just cheap inverters that are coming out of China. Probably have a multitude of different brand names on it. And this company, I will say, it seems like they screen their products pretty well. So generally, if you get from them, you're going to get some decent stuff and cheaply.